This is inverse normal practice for those of you that may have missed or want extra help. So the difference here is they are giving us a probability and we are finding the value where that probability happens. So you still start out by putting the mean on your picture. So I'm going to put the mean here, which is 20. I know the standard deviation is 3. And so I need to find a value where everything that is less than that value would be a probability of 0.348. So I know it has to be down here somewhere because it has to be less than 0.5. So I don't know what that number is. My calculator is going to tell me. I'm just going to put a K there. So when you use inverse norm on your calculator, you enter, it's called area, the area to the left, that's the probability because the area under that curve is probability. And then you put mean, standard deviation. So again, this is your, so when I ask for area, that's the probability. So inverse norm is under distributions right below normal CDF. Enter it in. You get 18.8. So the K value is 18.8. If you checked this, you could go do normal CDF from negative infinity to 18.8 and you would get 0.348. Okay, so again, a K value, there's my mean. A K value is 0.8. So this time the left of the number is 0.878. So that means my K is over here. So all of this is what we're talking about. That's 0.878. So you put it in your calculator. You just do second enter. You can bring back up the same thing. You get 23.5. Again, you make the picture, helps you check it, make sure your answer makes sense. The last one here, you don't even need to use your calculator because it says the area to the left is 0.5. Well, that has to be our mean value. Okay, so continuing on here, the probability to the left this time, the mean is 38.7. Probability to the left is 0.9. So I'm talking about all of this area way out here. There's only 10% to the right. And so my K goes there. Now, if you have some of you have a calculator that has a left, right, and center, you can choose that option too, but I'm going to assume that not everybody has that. So inverse norm. .38, sorry, 0.9, 38.7, and 8.2. Enter in your calculator. And you get 49.2, which should make sense. It's in the right place on there. Now this one is the one you got to be careful of, just like the binomial distribution. This is greater than. So this means we're picking a number that the area to the right is 0.8. So again, I put my mean on here. And I need to pick a K over here because everything to the right is 80%. 80% of the data is to the right. Now, if you have a calculator that has the left, right option, center option, you can just put that in and go find the area to the right and be done. The rest of us know that that is 0.2. And so we're going to do inverse norm with 0.2 because the total area has to add up to 1. So you get 31.8, which makes sense, right? It's smaller than the mean. There's only 20% area to the left. If you want to check it, you would do normal CDF, negative infinity to 31.8. Put in your mean and standard deviation, and you should get 0.2. Or you could do normal CDF and go from 31.8 to positive infinity, and that would give you 0.8. Let's go kind of quickly here. So this is a less than, so my K is going to be here. So I can just enter it as is. This is a greater than. It's bigger than half, so more than half is to the right. So what I would be putting in inverse norm is 1 minus 0.592, because that is the area to the left. If you have most of you have so you're doing 0.408. Everything else is just the same. I'm not going to do this last one. If you have a calculator that has a middle, essentially what this is saying is if you add a number and subtract a number from the mean, you get an area of 0.427. I'm not going to enter it all in, but I'll talk through it. So 0.427 is that middle. That means the outside, if you take 1 minus 0.427, you get 0.573. It has to be shared equally between those two outside values. So divide it by 2, you get 0.2865. So that is what you would actually use to find this first point. And then from there, you can use symmetry and say it's the same distance above as below. Okay, so those are inverse norms. You can check everything with normal CDF when you get your answer.